Okay, this is a continuation of the video for MAC 1140 Pre-Calculus, Section 10.2. We had started problem number 11, and I believe we got as far as talking about the vertex, as well as the equation, and we plotted some of it. This is what we had thus far. Let me fix this camera. Okay, so the vertex we had come up with as -2, -1, just based off the equation, comparing that to the formula from where it came. It was -2, -1. We also talked about how this -1 represented the 4a value, and that allowed us to get an a distance of 1/4 and a 2a distance of 1/2. I had started to plot the vertex, -2, -1, and we were talking about the direction in which it opened. If there's a square on the x, it has to open either up or down. Based on this -4a value that you're seeing here, it opens down, and therefore the focus is below the vertex. So when looking for the focus, which was the next question that I was about to answer, I was going to base that off of knowing that I needed to move downward, because the focus is always inside the parabola. So if this is the vertex and it opens like this, then the focus will be inside. So knowing whether you have to move up or down helps you to know, hey, should I change the x coordinate or the y coordinate from where I am starting off, which is this vertex. So vertex is listed as -2, -1. And then I am going to be moving downward to get to the focus. And when you're moving downward, you're taking your y coordinate and you're subtracting a specific distance. From vertex to focus, it's the a value. That's the difference that separates the focus from the vertex. So take the y value, which is -1, and we're going to subtract the a distance, which is 1/4. Okay, so if you're going to be at -1 and you're going to subtract another fourth from that, you can put it in your calculator if you want, -1 minus 1/4, and you will now be at a y coordinate of -5/4. You can just go -1 minus 1/4 and then hit math, enter, enter. The x coordinate is going to stay the same because these need to line up, the vertex and the focus. Okay, so the focus turns out to be this. That's one of the questions that they're asking. I had already answered the what the vertex was. So this is -2, -5/4. Okay, then moving to the equation of the directrix, the direction, the distance between the focus and the directrix is also, let's see, well, we can go from the vertex to the directrix because your focus is right here at -2, and then we're talking about -1 and 1/4, so they are just like almost exactly right on top of each other. Very tiny distance between these two, but your focus would just be tiny bit below it. So let's just say there, we know that we're opening that way. The directrix, remember, it's a line on the outside of the parabola. Doesn't touch the parabola and is perpendicular to the axis of symmetry. Axis of symmetry connects these points right here. So if you're wanting to get from the vertex to the directrix, then you got to go back the other way. The focus is below the vertex. The directrix is in the opposite direction, but lined up with these 2 points. So from this vertex, we'd have to go back up this way. Again, when you're moving up or down, you are impacting your y coordinate. These are also separated. The directrix is separated by a distance of a when you're talking about coming from the vertex. So it's going to be the y value plus a distance of a. That distance is 1/4. So just the y value plus 1/4. And this is the y value that we're basing it off of. So now remember, the directrix is not a point, it's a line. So all we need to know is what happens when we take this y coordinate and add 1/4. And you can put it in your calculator again if you can't do this in your head. It's just -1 plus 1/4. That would put you at -3/4. That would be your new y value. The directrix is a line, so it is named as an equation. This directrix would be horizontal and is therefore named as y is equal to. That is a horizontal line equation. Okay, so I also have the equation of the directrix, y equal to -3/4. Okay, so -3/4, let's see if I can see. This is 1/4, 2/4, 3/4. This is where the directrix would be. Okay, and then if I want to get a nice full graph with the proper width on it, then I should do the lattice points. So again, let's review which way this opens. It opens from the vertex and wraps around to give us the left leg and the right leg of the parabola. And those lattice points are right on the sides. They are lined up with the focal point. So you'd have to move to the left and to the right, a distance of 2a to get to those lattice points. So let's do those calculations right now. We're going to move to the right of the focus. Moving to the right impacts the x value, and it's always, focus is separated from the lattice points by a distance of 2a. So it's x plus the 2a value, which is 1/2. So it's -2 plus 1/2. And when you add -2 plus 1/2, you can put that in your calculator, you get -3/2. You can do a decimal for that if you'd like. And then the y coordinate is going to stay the same from the point that you just left from, which is -5/4. And then if you're going to move this way, then you have to take your x coordinate and subtract the 2a value. So it would be x minus the 2a value, and the 2a value was 1/2 once again. So it would be -2 minus 1/2. And -2 minus 1/2 is going to give you -5/2. Again, you can do those as decimals if you like. So -5/2 and -5/4. That -5/4 is just from the focus. It's staying the same. It is this one that's changing. It changed when we went this way. It changed when we went that way. Okay, so now we have the two lattice points. We have the lattice point to the right. And we have the lattice point to the left. Okay, so one of them is -1.5 and -1.25. I mean, I could write these here for you if it makes it easier for you to graph. Okay, so -1.5. I have to move these just because they're in the way. Let's remember that this is the focus because we're trying to line up with those. So -1.5 would be right here, and then come down to -1.25, lining up with that focus. Then the other one is -2.5. That's what this 5/2 is. Might make it easier for you to graph. And again, down at -1.25. So -2.5, and then we're going to go down to -1.25 and line up with the focal points. Okay, connect from your vertex, which is right there, through those lattice points to get the proper width on the graph. Okay, directrix is behind it, and we've already given the equation for that. And that completes all parts of number 11. Moving on to number 12, this time we have something where you're going to need to know how to complete the square in order to get this in the kind of form where you could see the shifts. In other words, the H and the K. See how you were given the problems like this, where you can just take the numbers out and state what the H and the K is? You're going to have to use completing the square to get it in the form of the way number 11 was given and the way number 10 was given. Notice that the problem that you are now being presented with has no parentheses, but only when it's in that parenthesis form can you tell what the H and the K is. So we're going to work towards that using a procedure called completing the square, which gives you the vertex of any conic section. Okay, so if you recall completing the square, and let's see, I think I may have skipped over one. I did skip over one. I skipped over 12. Oh, same thing though. You're completing the square here. You have no parentheses here, so you cannot tell what the vertex is. And if we don't know where the vertex is, it's hard to move to the focus or find the A value or any of those things. So completing the square. You can only complete a square on a family where you have both the squared term and the linear term, and that would be this family right here. So what you're going to do is you're going to keep these two squared terms, or you're going to keep both of the terms containing y's on one side, so y squared and the negative 8y, so everything belonging to the y family, since you'll be completing the square on the y family. You're going to go from a binomial to creating what's called a perfect square trinomial. If you remember this procedure, we did it in the appendices and in other sections in this book. Okay, then you're going to take anything that doesn't belong to the y family and move it to the opposite side. So we're going to move this 8x to the opposite side. We're going to move the 16 to the opposite side. And now we're going to complete the square. Okay, so completing the square, you have half of this negative 8, which is negative 4, and then you're going to square it. And this 16 that you get will turn this binomial into a trinomial that happens to be called a perfect square trinomial. Whenever you complete a square, that is what you're creating, a perfect square trinomial. All perfect square trinomials factor very easily. It'll be something squared here, joined by this sign. So if you want to know what was squared to get that, just take the square root of this first term. That'll be y. If you want to know what was squared to get that, that would just be 4. So what you've done is you've taken this perfect square trinomial, you've put it in factored form, but in doing that, it's beginning to look like the problems that you've been given for the last 2 or 3 problems where you had a vertex that was shifted. You're getting it into that form now. Notice that you are working with an equation here, so whatever you do to one side, you must also do to the other side to keep it balanced. An equation is a balanced statement. What you do to one side, you do to the other side. So what you end up having on this side is just negative 8x. Okay. Now what this has is a shift on the y-coordinate, so this has a vertical shift, but it does not have a horizontal shift. In fact, if you want, you can write it like this, but not that you have to. So no horizontal shift, but this does have a vertical shift. Okay, so when they say what is the vertex, this is the h value. X minus what would give you this right here, 0. And the shift on the y, there was no shift on this one, that's why it's a 0. And what would have to be plugged in as a k value if you were thinking of this as y minus k? Positive 4. So 0, 4. Remember, what the signs appear as in the actual equation, they are the opposite sign of that when you're getting ready to graph them. So when you name the vertex, they have the opposite sign of the numbers that you're pulling out of here. So it's a negative 4, positive 4. 0 can't change in sign. It is signless. Okay, so now we have the vertex. And if we're going to get the focus from the vertex, then we have to know what the a value is. But just looking at this right here, remember the coefficient right here of the linear expression, the coefficient will help you to get the a value because this stands for 4 times a. Okay, so 4a is equal to negative 8. That means divide by 4, divide by 4, a is equal to negative 2. That negative only tells you, helps you with respect to the direction. Okay, you have a square on your y. That means this is a sideways parabola which can open either to the right or to the left. But because of this negative right here, this is going to open to the left. And that will help us think about where the focus goes and where the lattice points are and so forth. Okay, so in this particular problem, I'm going to graph what I have so far. I have 0, 4 right here, which means that up at 0, 4, that is my vertex. Focus has to be lined up with that. I already know that it opens sideways and to the left, so the focus has to be out this way. And we're separated by a distance of a. Remember, you want to think about that distance in its positive sense. This would be your a value. And 2a, which will help us find the lattice points, will be 4. Okay, so if I'm going to move a distance of 2, 1, 2, that would mean this is where the focus is. Okay, and you can, you can take, that vertex and work on it, or you can just tell what your focus is right here. If you're just working with the numbers, and this was the vertex, and you were trying to move to the left, that would just mean take this x coordinate and subtract whatever that a distance is. And that would put you at, just like this shows, negative 2, positive 4. And you can see that in the graph. Okay, so knowing that this is the focus, and we're working off the focus in order to get the lattice points. Okay, let's remember, this parabola opens like this. So there's a leg right here. One side of the parabola is here, and on that side of the parabola is the lattice point. It is directly above the focus. Then we have another side of the graph down here, and the lattice point on that side is also in line with the focal point. It's a distance of 2a up, 2a down. So we can get that right off of the focus point. So our focus point, which we just found out by moving a units from the vertex, was negative 2, 4 in this particular problem. Okay, and then to move up this way to hit this side of the parabola, let's see, if I'm going to move up, that means I'm changing my y coordinate. I am adding a distance of 2a. So the y coordinate, and our 2a value was 4, would get me, let's see, it would keep my x the same, but I would take the y value and add 4, so that would be 8. So that is my upper lattice point. It's the lattice point above the focal point. And then if I want to get the lattice point that's below this, then I take the y-coordinate and I subtract the distance of 2a. So it would be y minus 4. So leaving the x-coordinate the way it is in the focus, but then impacting the y-coordinate by subtracting 4, that minus 4 is 0. So I have one lattice point, upper lattice point, which is at negative 2, 8, and I have the lower lattice point, which is at negative 2, 0. And I can complete that graph with those points. Okay, so negative 2, but moving up to 8. Looks like 8 to me. All lined up with the focal point. And then when you're going to go do the other one, which was negative 2, 0, that would just be negative 2 right there, again lined up with the focal point. Just go from the vertex, connecting through those lattice points. Okay, so the equation of the directrix is still being asked, besides the fact that you have to create a graph. Okay, I moved up from the focus, down from the focus. I had calculated both of those values first, negative 2, 8 and negative 2, 0, and then used them to get the graph. They still want the equation of the directrix. Remember, the directrix with respect to the vertex, it's the same distance that it is to get to the focus as it is to get to the directrix. Let me move this up a little bit. And if I had to move 2 units to get this way, I have to move 2 units to get this way. Okay, this directrix is always perpendicular to this axis of symmetry. So it's a line that goes just like this. Okay, so this line right here is called x is equal to 2. It goes right through the number 2, and it's a vertical line. All vertical lines are called x is equal to, and then the number that they shoot through on the x-axis. So, you can do some of these things just by looking at the graph. You can calculate the points. I mean, doing the lattice points and knowing how to move from the focus to the lattice points, that'll really help you to get that done when you do it this way. Some of the other things you can get directly from the graph. Okay, number 13, same thing. You're going to be completing the square. You can only complete the square on the family that contains both the square and the linear term. Okay, so that would be the x family here. So we're going to keep the x family together, but leave room to create that third term and create a perfect square trinomial. And then any other terms should be on the opposite side. Okay, so you take half of the linear coefficient when you're completing the square. That'll give you 5, and then you square it. Okay, so that'll give you a 25 right here. And if you're going to add 25 to this side, you have to add 25 to this side. Okay, so you're going to take this perfect square trinomial that you have just created. It used to be two terms. Now you turned it into a trinomial, but it happens to be a perfect square trinomial, and they all factor like this, which gets it in the form of a shifted graph. In order to get it in this factored form, all you do is take the square root of this front term, like I did in the previous problem, and the square root of this back term. And then you join these two terms by the sign in front of the linear term. Let me write a little bit nicer here. Okay, so this will be a plus. Okay, then on the other side, what we have is negative 21 plus 25 is 4. And you can also factor that. So this is going to be 4 times y plus 1, showing the shift, the vertical shift, and x plus 5 over here showing the horizontal shift. So when you're determining h and k, remember you are comparing what you see here, this equation, to the formula that was plugged into, that you could possibly plug into in order to get this equation. So that base equation is x minus h squared is equal to 4a times y minus k. That would mean that what had to be plugged in right here in order to end up with a positive 5 would be negative 5. Remember, when you find h and k, you're finding the vertex. And what would have had to have been plugged in here would have been a negative 1 for the k value. So we now know the vertex. This 4 represents the 4a value, so now we're going to know what a is. Divide by 4, you'd have a is equal to 1. So let's remember that's the a value, which can help us get from vertex to focus or vertex to directrix. If we're trying to get to the lattice from the focus, then we're going to need this 2a value, which would just be 2 times 1 or 2. So we have both of those values to work with. Okay, so the vertex was negative 5, negative 1. So negative 5, negative 1 would be right there. And then, you know, you can get some of these answers just by moving your finger if you know which direction you're going in. I mean, look at what is happening here. As we've been talking about throughout all these problems, when the square is on the x, you're opening vertically, either up or down. Now go look at the sign on this 4a expression, this coefficient. If it's positive, that means that you are opening vertically and you're opening up rather than down. Okay, so this problem is going to, you know, the graph is going to be looking like that. So when you know those sort of things and you go to try and find things like the focus, you can just figure out what the a value is and go and plot the vertex, which is negative 5, negative 1. And if you know that you're opening up this way, that means you're going up to get to the focus. And you can come over to the side and calculate it, as I have done in many problems, or you can count it out with your finger. Okay, so you'd be moving, let's see, what was the a value? The a value was 1. So if we're right here and we line up with this vertex to get to the focus and we just move one space away, then we're right there. That would be our, let's see, yeah, that would be our focus. Okay, give me 1 second. Okay, so this is the focal point right here. So that focal point is, since you just moved 1 unit up, and the reason that we moved 1 unit up is because this distance of A. From vertex to focus, it's a distance of A. Okay, and we knew that we had a parabola that opens up, therefore the focus had to be in that direction. Once you know the focus, which is negative 5, 0. Those are the coordinates of that focus, negative 5, and it's right on the x-axis. Then in order to get the equation of the directrix, we could work on that also. I think what I'm going to do is go ahead and finish the graph. So if I'm going to finish the graph, once again, let's reacclimate here. You're opening to the right. You're opening to the left. If you land on the right side, you're moving from the focus. You're moving a distance of 2a to get this way, 2a to get that way. Okay, so moving to the right, I'm going to affect my x-coordinate. And I'm going to move a distance of 2a to get to that right lattice point. Okay, my 2a value was 2. So we're talking about taking the x value and adding 2. So negative 5 plus 2 is negative 3. Leave that y coordinate alone. Then if you're going to go and get the left lattice point, leave myself a little bit more room here, then you're going to go the x value when you're moving to the left, and you're going to subtract 2a. So that would actually be the x value minus 2. So negative 5, take away 2, negative 7, leave the y coordinate alone. So you now have your two lattice points, the lattice point to the right, the lattice point to the left. And this is the left lattice point. Okay, so plot these. This would be negative 1, 2, 3, 0, and then negative 7, 0. That would be right there. So right from your vertex, you can open right through those lattice points to get the correct width on that graph. Okay, so let's see. The other thing they wanted is the directrix, and the vertex to the focus has a distance of a, but so does the directrix. You can just move down below. Let me get this out of the way so I can put it in the proper place. I went 1 up to get to the focus, which was at negative 5, 0. And then this vertex was at negative 5, 1. I'm negative 5, negative 1, and if I just move 1 the other way, then that's where the directrix is. And that directrix has an equation of y is equal to negative 2. It's a horizontal line right through negative 2. Okay, that answers all questions and completes the graph. Okay, moving to number 14. This one says, write an equation for the parabola shown to the right. So in this particular problem, this is like one of the other ones that we've had thus far. You can tell what the vertex is. There it is right there. You also have a random point and random xy point on this graph. So this can be used for x and y, and seeing the direction that this opens in and the fact that it has a vertical shift but does not have a horizontal shift, that means that the equation is going to look like this. It's got a vertical shift. In other words, a value that's been subtracted from the y coordinate causing it to shift vertically. It opens to the left rather than to the right, therefore that 4a value is going to be negative. And there is no horizontal shift, meaning there's no number. Nothing has been subtracted from that. And so you could just write an x there. When you see that it has not been horizontally shifted, it's just been dragged down, then you could just write an x instead of x minus 0. Okay, so then let's see, the h and the k value, we have that. And we also have a random point. So we have something we can plug in for x and y. And we also have something that we can plug in for h and k. I already plugged in for, this is h and k right here. I already plugged in for that. Okay, so let's continue plugging in right here. The k value is negative 4. And the y value is negative 3. So this would be negative 3 for this y value right here. And then minus the k value, and that k value is negative 4. So it's the y value minus the k value squared, which is really negative 3 plus 4 squared, which is 1 squared. Okay, and so that 1 squared is just 1, and that's equal to negative 4a, negative 4 times a. And then here it's x take away nothing, or just x. You can just go plug in the x value at this point. So the x value was negative 1. I plugged that in there. So this ends up being 1 is equal to negative 4 times negative 1, 4, 4a. So a turns out to be 1/4. So we got the a value. We can also tell what the 2a value is if we need it, but let's go ahead and write an equation for the parabola shown. Okay, so if we know what this a value is, and that's all we were really waiting for, we can go right back up here to this basic formula, which was y minus the k coordinate. That's the k coordinate, so y minus negative 4 squared is equal to 4 times the a value, and the a value was 1/4. So let's continue copying this. So this is negative 4 times the a value, just because it opens this way. The a value turned out to be 1/4. And then x take away nothing is just x. Now we're just trying to give an equation with x and y. So y plus 4 squared is equal to 4 times 1/4 is just negative 1 x. And this is your final equation. Okay, moving on to these two application problems. So in example number 15, it says a satellite dish is shaped like a paraboloid of revolution. I can draw one of those for you. The signals that emanate. So first let me just draw this paraboloid. That would be like the top, and then this is just like a cross section of it. And I'm going to put this on a y and an x axis. And this would be the parabola part down here. Okay, now what they're saying is that from here to here is 12. And I'm going to make this my y-axis right here. And then I'm going to put this right at the x-axis. And they're saying in this problem that the signals that emanate from a satellite strike the surface of the dish and are reflected to a single point. I mean, this is just the way your headlights are made. They put the light right at the focal point, and the cup that holds the headlights on your car, they're shaped just like this, like a paraboloid of revolution. Okay, so this is going to be your focal point right here, and I believe it says that if the dish is 12 feet across, I made it 12 feet across, and its opening is 2 feet deep. So they're saying like from here to here is 2 feet. And then going across, it's 12 feet. And then the receiver on the satellite is placed right there at the focal point. So at what position should the receiver be placed? They want to know the coordinates there at the focus. So coordinate, the receiver is supposed to be placed right at the focal point so that when the light comes in like this, It shines off. So what are the coordinates of the focus? This is just some stuff it says in the, in the actual graph. Okay, so when the parabola is shaped like this, as we've looked at in all these problems, it would be x squared. It is, vertex is right here at the origin, so no shifting. This would be 4a times y, where this coefficient is positive, meaning that it opens up. Okay, so if I'm going to look at some points that are on, that I could use for actually x and y, I could talk about this point right here on the parabola, or this point. This point right here would be 6 units up. If this is 12 all the way across, then from here to here is 6. And it would be 2 units up in the air. Okay, 12 all the way across, which means half of this is 6. So to get to that point right there, 6 out, 2 units up. So I could use those in this equation. I could put 6 for the x, that is a point that's on the parabola, therefore I'm allowed to plug it in for x and y. And then it would be 4 times the a value, and the y partner for this x value would be 2. So I would end up with 8a is equal to 36 dividing by 8 on both sides. And I would have a is equal to, let's see, 36 divided by 8, or 36 divided by 8. I'm putting that in my calculator. I got 4.5 for my a value. So when they want to know where is the focal point or the focus, well, if you're right here at 0, 0, for your vertex, and you're going to move a units from here to here, that just means that you are 4.5 units up in the air. Okay, from here to the focus, which is where the receiver is going to be placed, you're just moving 4.5 units up in the air, which is this a value that I just found. Okay, and so this would be final answer. The receiver should be placed at 0, 4.5 on a grid. Oh, no, wait, now what does this say? The receiver should be placed how many feet above the base? Okay, this would be the base right here. So if I'm answering not in coordinates, but answering the way this question is being asked, then I would just respond 4.5 feet from the base, where this is the base and that's the receiver where the focus is. So 4.3, just in answering in the manner that they're trying to get us to answer, from the base of the dish along the axis of symmetry, meaning that this focal point is right on the axis of symmetry. Okay, last example. Thank you. All right, so this one says that a bridge is built in the shape of a parabolic arch. The bridge has a span of 160 feet from here to here. So I'm going to draw a bigger picture here. Draw this on a XY axis as well. Let this be Y, let this be X. This one says it has a span of 160 feet, this parabolic bridge. So that means this would come in at 80, and this would hit at negative 80 to give you a total span of 160. This vertex here, it says that the height, which they're talking about where the vertex is 20 feet. So the coordinates right there at the vertex are 0, 20. It's 20 units up in the air. Okay, then the kind of parabola suggested by the way that this opens, which has been one of the main things emphasized in this section. Parabolas that open either up or down would be x squared. This vertex is not horizontally shifted to the right nor the left, so instead of x minus h, just x squared is equal to 4a, but look at the way it opens down. So because it opens down, that 4a coefficient should have a negative in front of it. And then notice that this vertex is vertically shifted. So instead of just a y here, it's y minus k. Okay, so this describes the parabola and the way that it opens downward. Okay, we have a vertex here, as stated, of 0, 20. And then the focus would be whatever the A value is. So this would be the A value, and the focus would just be that 20 minus whatever the A value is. Now we're trying to, let's see, what's the question here? Choose a suitable rectangle. We're trying to refine this equation right here. So one thing we could do again is we can look at points like we have in some of these other problems, points that this graph passes through. Like for instance, it passes through 0, 20. Let me look at this. So we have the vertex of 0, 20, and it passes through 0, 80. That's one of the points. We could use this one or this one. So right here, this parabola passes through 80, 0. That point is 80, 0. So if we were going to try and refine this equation, we could put this in for x and this in for y. So it would be 80 squared, and then this is to try and help us find 4a so that we can go on and answer these questions about choosing a suitable rectangular coordinate, choosing a suitable rectangular coordinate system and find the height of the arch at distances of 10, 30, and 50 from the center. Okay, so this is negative 4a, and then this is going to be my y coordinate right here. I'm using this point right here to plug into this equation so that I can find the a value. I'm trying to get rid of the other variables. So this would be 0 is the y partner when using 80 for the x partner, and then minus the k value at the vertex. That would be at the vertex that I'm getting this value from. The vertex k value is this 20, where it's 20 units up in the air. So y minus that k value. Okay, so 80 squared would be 6,400. This would be negative 4a times negative 20, which would be negative 4 times negative 20. That would be 80a is equal to 6,400. Divide by 80, divide by 80. And you get a is equal to 80. Okay, so that being the equation can be refined now, rewritten using the a value. So here we were back up here when we started and we didn't know what the a value was. We plugged in a random x and y value, which is this point. I could have plugged in that one if I wanted to, as well as the k value at the vertex. Then rewriting this equation now, it would be x squared is equal to negative 4 times a, that would be negative 320, as the coefficient of the linear term. So this is the actual refined equation, and now we can use this equation in order to answer these multiple questions that they're asking in this problem. So, and find the height of the arch at distances of 10, 30, and 50. So when they say at distances of 10, 30, and 50, we're talking about if the x value is only 10, do it at 30, and also do it at 50. So I'm going to finish that here. At x equal to 10, don't have much room left to show work. I'm going to be using this equation. It's going to be using that equation right there. 10 squared is equal to negative 320 see, now I have something wrong here. Okay. Yep. Let's see, I plugged into this. So this was x squared, and then it was negative 4 times a. That gave me, and I was supposed to have, fix this before I go using it. We're supposed to have y minus the k value. So the k value was 20. So that was the value there. That's the complete equation. I'm going to copy all of that. Okay, so plugging into this, it's going to be at x values of 10, so it would be 10 squared is equal to negative 320 times y minus 20. So this would be 100 is equal to negative 320y. And then this times this is positive 6,400. Okay, so I'm not going to be able to show too much work here, but if I subtract 6,400 from this side and this side, I would end up with negative 320y. And if I went 100 minus 6,400 from each side, that would be negative 6,300, and then divide by negative 320 on each side. And I would get that when x is equal to 10, so divided by negative 320, it would be 19.69. And you could repeat this for the other values that they have here. So we did it for 10, and then I have enough room to do it for 20 here, but then I'm going to stop there. Okay, so using this same equation right here, when you have it for 30 squared, it would be negative 320 times y. This times this is that positive 6,400. This would give you 900. This would give you negative 320 y plus 6,400. So if I was going to subtract 6,400 here and 6,400 here, 900 minus 6,400 is negative 5,500. Is equal to negative 320y, and that just gives you y is approximately, I think they said round to 2 decimal places here. So to get y here, divide by negative 320, divide by negative 320. And I got 17.19. So I did 2 out of the 3 final answers, but that'll show you exactly, oops. See if I can get it on the paper, 17.19. Okay, so this was at x equal to 10. This was at x equal to 30. And that completes all the examples for section 10.2.